Hello, this is going to be a quick video tutorial on how to use a debugger, specifically with C++ and the Visual Studio Code CMake extension. I'm a big fan of debugging C++ in this manner, just because most of the projects that I've used use CMake, and so it's just kind of convenient. Without further ado, let's get into it. So the first thing is I just want to show you like what a debugger is. So there are two main C++ debuggers. One of them is called GDB, and the other one is called LLDB. And LLDB is only for macOS, so I will be using GDB. And so the first thing we need to do, let me just remove some old files really quick. Okay, so the first thing that we need to do is we need to run CMake. So let's make dir build and cd into build. And usually you just run CMake ... Of course, CMake ... gives us now the CMake list file. But in order to enable debugging, we need to add an additional thing that is CMake build type. And then we set this equal to debug. And there are multiple different things that you can assign here. You can also do release, and I think you can do like release debug or something. But in this tutorial, I will just be showing you debug. And so let's run this. Oh, my mistake. So we are defining this, this variable here. So we need to do -d to define this. So yeah, okay, this should now work. And so now this is creating our make files now using CMake. And specifically, so this make file, what it has is when it calls G++, it will now call G++ with -g. And -g will add internal debug symbols into our binary. And so this allows now GDB and LLDB to access the like internal lines of our C source file. So when you do -g, it will now embed like this file. It will embed this file into your binary, and so now you can see like every single line of code that is being run as the program is executing. Usually, you just run the code and it doesn't actually keep track of the original source. So yeah, okay, so that's what -g does. And great, so we created our make file, so now we can run make and ignore these warnings. They kind of reveal a little bit of what's gonna happen pretty soon. But yeah, so now we ran make, so now we can run GDB, and we can do that with GDB, and we can now plug in our binary, and our binary in this case is just sum of primes. And something else that I recommend getting in the habit of is just doing --args to now allow passing in arguments to this binary. So if we wanted, we could pass in like whatever additional command line arguments or something, whatever, I don't know, you can do whatever you want. In this case, it actually doesn't matter because sum of primes doesn't take in an argument right now, so we can remove this, but I'll leave it. And great, so now we are running GDB, and this is just a little warranty thing that it shows. And in order to run this now, we can just type in run. And it's a little bit hard to tell, but unfortunately, we've actually run into an infinite loop here. In this code, like what normally would happen, let me close that really quick. So yeah, normally if you just run sum of primes, we can see that we get an infinite loop. And so this is quite challenging to try to deduce where this infinite loop is in this code. So that's why this is a good example of trying to use GDB. Otherwise, we could add a bunch of print statements, but that takes a while. Like we'd be kind of nice to just know like what lines of code it's stuck on. So okay, yes, let's run GDB one more time so I can run it again and then type run. And okay, it's being stuck on the infinite loop, and we can stop the infinite loop with Control-C to pause. And then after that, we can see that we're currently stuck in if is prime. And if we want, we can step through and see what's going on. And it looks like whatever, it's doing some things. You can see whatever, it looks like it's while if prime, and then checks that and returns, and it looks like, okay, yeah, so it looks like there is some sort of infinite loop here because it's calling if prime like multiple times. So that's probably our issue, but it's a little bit confusing to be in this command line interface. So I mean, you can look up tutorials on how to use this, and it's not too difficult, but it's a little bit more clear if we use the VS Code functionality that's just baked in that offers debug support. So let's quit out of this, and let's now run it using VS Code. So yeah, so with VS Code, the first thing that you need to do is add this line into your .vscode settings.json. So yeah, go and look at this and type this all in. So what this is right here, what this line does is it will just specify the build directory of your CMake files. So yeah, and we can see that our we have a build.vscode directory right here, and this is where it will be putting all of its things eventually. Yeah, it shouldn't exist. We can see that I deleted it a little bit ago, so it doesn't exist. But now if we now run CMake, so this is the CMake extension icon right here, and if we click on this, and then let me just unpin that, then now we see this right here, and if we want, we can run any one of these. We can build it, or we can run our tests or debug. So yeah, in this case, let's launch the debug terminal, and yeah, now we can see that we should have the build.vscode folder, and it's compiling everything, and it's about to run everything, and there we go. So now it is running, and the way we can tell it's running is because now we get this additional toolbar up here, and this toolbar has a stop and restart and pause functionality, and as well as our step functionalities. So let's go and pause it. And okay, yeah, so we can see it looks a little bit familiar from our command line. So we can see it's calling is prime, and it's returning 0 here. So we can step through this program and see what's going on. So let's step, and okay, so it's checking while I is less than n is prime. So I'll tell you really quick what this program should be doing. So yeah, so if we go and look at our main, it's pretty straightforward. So the first thing is, so this is saying if we do not plug in any command line arguments, then just set n to 10. Okay, so at the moment, n just equals 10. In fact, we can even hover over n, and we can see that the value is currently 10. Yeah, and I can even go into this debug bar right here, and if I click on this, and yeah, so now we can see that the local variable, we can even see that n is 10. So yeah, in this tab right here, this keeps track of all of the local variables that are currently assigned in our function. Yeah, and so, okay, so n is equal to 10, that's good. But then it is currently trying to run this function that is called getPrimes. And then after it runs getPrimes, so this should return a list of primes, and the length of the list of primes should be equal to n. So we should imagine that in this case, since there's 10 primes, it should be whatever, 2, 3, 5, 7, and then like all the way up until the 10th prime. And then after we have this array of primes, then it will sum them all up, and then it should print out that the sum of the first 10 primes is, and then it should print the sum of whatever the first 10 primes is. So that's what our main function is. And yeah, and we can see right here, so this is our call stack, and this shows us exactly where our, where we are in execution. And we can see that, so we've entered the main function, and then our main function has called getPrimes, and yeah, we can click on this. So our main function is called getPrimes, and then if I click on this, then we can see that we are currently at this line. And if we now we can step again, and if we step into, so we can click the step into function, and if we click on that, then now we can see we've entered now a new function. So we have a new function call added to our call stack, and yeah, so now we can see that we are right here. And yeah, and okay, so let's now take a look and see what the issue is. So and so we can see we have a local value of 2. Okay, so this is checking is 2 prime, and the answer to this, of course, should be yes, 2 is prime, but we can see that this check right here, this is checking whether 2 is even, and it does recognize that it's even, so it's incorrectly assuming that it's not prime. So yeah, we can step into this and we can see, oh, okay, so yeah, this is saying that 2 is prime because it's even. So this is very helpful, that the debugger is able to show us exactly what line we're failing on. Okay, so let's go and edit this, and let's just add a quick little check that's just like if x equals 2, then I don't know, just return 1. That seems useful. And maybe we'll just add another check that's just like if x equals, or maybe if x is less than 2, then return 0. I don't know, that sounds good. Okay, and now, so we've edited our code, and so if we keep stepping through, or actually it's going to be a little bit corrupt, like it's going to get a little weird. That's because even though it's highlighting these 2 lines right here, it's actually thinking that it's highlighting these 2 lines because we just moved our entire code around. So in order to get this to be like, whatever, not scrambled up, we have to stop execution. So let's hit stop. And great, so now we've stopped it, and now we can rerun debug. And also another thing I like to do is I like to just pin the debug command right here, so I can just pin it, debug. Okay, cool, so now it's pinned right here, and now I can run this. And it's recompiling now, so it's adding back these, and it's adding the debug symbols, and unfortunately it still looks like we are in an infinite loop. So yeah, if we want, we can pause it, and okay, so it looks like it's still stuck here, unfortunately, and we can go to our local symbols, and we can hover over this, and we can see that x is equal to 4. So that's weird. Okay, so does this work? I mean, it should. So if I step over and step over, okay, yeah, so it looks like it's going to return 0, and yeah, it looks like it does. And in fact, oh, I guess it didn't do it here. Anyways, yeah, so it looks like it should have returned 0, but I don't know why we're still getting an infinite loop. Well, yeah, I don't know. Let's take a look. So if prime, so if this is prime, so this is saying that 4 is not prime. So if this is not prime, then it should just continue. So let's keep stepping over. Yeah, so 4 is not prime. Okay, well then it just keeps keeps going. But actually what should be happening is we should be checking a different value of x every cycle. Like we should imagine that first, like it checks 4, and then it's like, oh, like did 4 work? And it's like, no, 4 didn't work. It's like, okay, so we should probably be checking 5 next cycle. So so let's go and move this line down right here. I think this is the offending line, and that will now make it so that x will increment every cycle, even if x is not prime. So okay, let's go and stop this and rerun this. And okay, great. This is fantastic. We're getting a different error now. This is wonderful. And so this is really cool because VS Code will actually show you the exact line that you are getting a seg fault at. And this is wonderful, but in case you don't have access to it, in case you don't have access to like VS Code, or maybe your debugger is like completely broken beyond repair, there's another really great way of double checking where your seg fault is happening, and that is called your call stack. So I already kind of mentioned the call stack. There we go. Yeah, so right here we can see that. So first we ran main, and this was great, but then we called sum. And inside of sum, at this particular line, we get the seg fault. And just to like really hammer this point more, so let me show you. So if we were to run, here, let me remake this. Yeah, okay. So now we've made this, and we can see, yeah, if I do / sum of primes, we get a seg fault. And if I now run gdb sum of primes, whatever, do this, then run. Then cool. Okay, yeah, so this is what the GDB output looks like in a seg fault. So we can see that the program received signal sev segmentation fault. Okay, and yeah, and it shows you exactly what line it's happening at, and it's showing you that the offending line is right here, and we can even go and click on it. I guess it's getting angry at me because I have spaces in my path, so I guess it's not working, but yeah, whatever. It's showing us at line 10 of sum of primes that we have an error. Another thing that you can do that's super important is you can type in the command backtrace, and so this will show you every single function that was run in order to get to this line of code. So this is the same thing as your call stack. This just shows you exactly like what lines of code were run in order to get you to this segfault. So you can also just do you can also do BT, which is an abbreviation for backtrace. So, okay, very important. This is like a keyword that anytime you're in a job interview and you're asked, how do you find a segfault? The correct answer is GDB backtrace. Or you could say like, I'm using VS Code and and it like prints it out very nicely for me. But the correct answer is backtrace. So, okay, that'll be on your quiz. Very important. Don't forget it. Cool. Okay. GDB backtrace solves segfaults. Okay. Great. Okay. So finally, okay. So we have a segfault here, and you may be thinking, okay, so what does a segfault mean? Let's take a step back. So a segfault happens anytime you try to access memory that your operating system does not grant you access to access. So we can see right here that our value of array is when we hover over it, it shows that the pointer value is actually pointing to 0. So we're not able to write to address 0. So this is not good. So array of 0. So that's why we are getting this segfault. And okay, so let's go back into main then and see like, well, why does this value equal 0? Yeah, we can see that the primes equals 0. Okay, that's unfortunate. So get primes is returning the incorrect value for some reason. So I think the issue is now we need to go into get primes. So if we want, we could now like hit restart and then try to pause it really quick in order to see what happens at get primes. But a better way to do this is we can add a breakpoint. And we can add a breakpoint by just clicking add breakpoint right here, and it adds a little red line. We can also do this with whatever breakpoint command if we were running not in VS Code, but I'll just show you VS Code. So great. Let me hide that. So okay, we've just assigned this breakpoint. So now we can go and restart execution with this button. And it is restarting. Okay, so now we are at this breakpoint, and we can see that primes is currently not set, so it is just gobbledygook, doesn't exist yet. So let's step into this function, and let's go and add another breakpoint. So it looks like result is not currently set. So so whatever, we can add more breakpoints, and we can hit continue to this point. And so now we can see that result is working. It looks like it correctly created this this array of values. Okay, and it has some garbage in there, but that's fine because it's going to assign them all. And and if we want, we can now fast forward, and so now it will correctly fill this all with all of the proper primes. Looks good. And now result, it's all working. And but then the second that we return from this, then now watch what happens. Immediately primes is just immediately set back to 0. And the reason for this is actually because of this line right here. And actually the issue is that this is a stack defined array. So the second that we leave this scope, this like array will no longer exist. So a little bit confusing. So when we return result, we're actually returning a pointer to result, but result will be deleted like when we leave this function. So actually, we're just returning 0 because this pointer is just deleted. So okay, so the way to fix this is now we can just say instead of int result, we can now say we want to do a heap allocation. So we can say new int with a size of 5. Size of n. Yes. Cool. Okay. So now we can grab it from that, and I think that all looks good. So great. But of course, anytime that we do new, we also need to call delete. So let's just make sure that anytime that we grab a pointer from get primes, that we're also just freeing it at the end. So let's go and just do delete, and we can do delete n. Okay. And and delete primes. Cool. And this is the notation in order to delete an array, a pointer array. So, okay, let's go and stop this and then rerun this. And so hopefully that has now fixed our seg fault. So, okay, so now we can run again. And okay, so yeah, result is now this pointer, and we can see that it's currently only showing 0. And that's a little bit confusing, but because remember, so before result showed like a big array, but here it's only showing 0, and that's because it is only showing the first value inside of result. So if we want, we can keep stepping through. So we can step, and then yeah, and if we whatever step, then whatever result you can now see is equal to 2, which is the first prime. So that's all good. But if we wanted to actually see the full value of result for a pointer array, what we would need to do is add an expression to watch. And we can do this. Let me see if I remember this. So I think it's primes. So you want to print you want to dereference this. So if we just do this, let me just do it. So I guess in this scope, so we're currently in the scope of get prime. So let me just do results first. So if we print this, then now we can see that it is giving us 2. But instead, we can change this to now specify this is an array. If we add this @ symbol, and now we can print the size of the array. So if it was 2, then we can show that now it has two of these guys right here. And yeah, if we keep stepping over, then whatever. There we go. Now you can see it's 3. But this size, of course, is not 2. This is actually a size of n. So we can even put in variables here. And so yeah, we can see it as a size of n, and n is set to 10. So there we go. It looks like it's fully printing out now. So this is the notation for displaying a pointer array, yeah, using GDB. And this works too if we wanted to now print out. We could just type in the debug console right here. We could even dereference whatever is result at n, and whatever. This will now print it out, and we can see all the values. Cool. Okay. Great. So I think everything was working. Okay. So let's just keep going. So great. So now result is all filled, and this is great. Actually, we want to check here, of course. Yeah, so we can see it's all filled. Last value is equal to 29. This is great. And if we run, and looks like it exited. And I guess if we check terminal, okay, great. So it looks like, yeah, correctly finished. It says the sum of the first 10 primes is 29. But actually that's not correct, because we know that the largest prime is equal to 29. So obviously the sum of the first 10 primes is definitely going to be more than 29. So okay, unfortunately we have another issue here. So yeah, so what we can do if we want, so we can look at where this result is being calculated. So the result is being calculated in sum. So okay, so sum is for some reason not working, and so okay, let's just set a breakpoint for here and just see what happens. So great. So let's just rerun this, and okay, and we can get rid of this breakpoint and continue. And okay, so now we're in sum, and okay, let's just see what happens. So okay, so total is currently equal to well, currently it's garbage because it's not assigned, but that's fine. So then but then we assign it here, and okay, so it's equal to 2, and then it should be, oh, so here it says it's 3, but it should be equal to 5, right? Because 2 plus 3 should be 5. But then if we do it here, then now it equals 5, and then 7. So actually, looks like the issue is we just we misaligned this. Should actually be plus equals instead of equals plus. So whatever, rookie mistake. No problem. Let's just stop this and recompile, and now this should be all good, hopefully. Yeah. So okay. So now we can step over, and looks like, well, it's adding properly, but our total was not reset. So let's of course now go and set our total to 0. Okay. And yeah, and this should be good. And you know what? Let's add a just to like make sure that maybe things are good, we can add like a special breakpoint here, and maybe we can say like stop at this point, but only when sorry, I have to stop this. So let's now create a new breakpoint, but let's stop in this array only when I is maybe equal to like n minus 1. So only like right at the very end. Well, we can actually do that. We can do a lot of like cool modifications to our breakpoints. So yeah, we can see, so break when expression evaluates to true, and or you can do hit count or log message. You can do all sorts of things. But yeah, so let's break when I equals n minus 1. Okay, so yeah, so that now in theory, when I equals 9, it should now stop at that point. So let's go in and rerun this. And cool. Okay, so let's check I, and I is equal to 9. And cool, it looks like our total is looking much higher, much more realistic. And I guess if we step one more time, then now it equals 129. And I will say that that is actually the correct answer here. Yeah, and we can see the sum of the first 10 primes is 129. So fantastic. We have now debugged this program to its fullest. This is wonderful. Yeah, but breakpoints can go really deep. You can do all sorts of really cool editing on them in order to, yeah, you can even print the values of classes and all sorts of things. So yeah, this was just a quick little introduction. I guess it's a half-hour introduction, but yeah, thanks for watching, and I look forward to seeing all of you becoming successful with debuggers in the future, and also passing all of the debugger questions that will be on your quiz. Okay, great, thank you.